Now, today I'm going to be sharing my interpretation of the relationship between the unit circle and the sine wave. Now, a lot of people I've seen do this demonstration where they start with the unit circle and then consider the height of the y value of the unit circle as a point rotates around and show that that can draw a sine wave. And I'm not sure I believe that that's true. So today I'm going to see if I can do the reverse by starting with a sine wave and then see if I can use that to draw the unit circle. The only trouble is, I don't know how to get the sine wave. How do we define a sine wave without using the unit circle in the first place? So I'm going to see if I can approximate it. Now, for my first approximation, I'm going to say, well, maybe the sine wave is just a linear function. So I've drawn myself a linear function here, and I'm going to let a point span across that linear function. Now, as my blue dot tracks up my linear function, you'll notice I've started to draw out a circle. So in this circle, I've got the angle measured from the x-axis to be equal to the x value of my point as we go up the line. And then the y values have to be the same. So this is the height of a point on the circle is currently equal to my approximation of the sine wave, where my approximation says it's just a straight line. And as you can see, it's drawing a perfect, oh no, that's not a circle at all. It started off really well, and then it went wrong. Okay, well, maybe the sine wave isn't a straight line. Maybe that's too simple. Maybe I need to do something else. So how about we say the sine wave is made up of a linear part and also a cubic part? I'm now going to edit my function, here we go, to say maybe it's actually a cubic function instead of a linear function. And hopefully this is going to trace the unit circle. Well, let's see, we go up and we've nearly hit one. And oh no. Oh, that's not quite the unit circle I had in mind. What happens if I go down this way as well? Is it going to do something interesting? Yes, it's made a little heart. How lovely. Well, as pretty as that is, it's not the unit circle that I promised. So maybe my approximation is still too simple. Maybe the sine wave is not a cubic. Maybe it's a pentic. Maybe it's a fifth order function. So I'm now going to adapt my unit circle to make it a pentic and see what this does. This is going a little bit better, and then it seems to go wrong at that point there. Still a pretty function, still an interesting shape. Remembering here that the rotation of the point I'm tracing is equal to the x part of the dot, and the height is equal to the y part of the dot. Interesting curve, not a unit circle. Okay, so maybe it is a seventh order function. Notice I'm going up by 2 orders each time. So this function I'm currently drawing has both linear, cubic, pentic, and heptic parts to it. And I think this is going to be a little bit more, there we go, a little bit more hopeful. No, still not quite right. Still not tracing that unit circle, not even in the naught to pi region. I'm most interested in naught to pi. After that, I'm less focused on whether this is going to work. But in naught to pi, it still hasn't quite done what I wanted it to do. I'm going to get this other interesting heart-shaped part. There we go. Oh, and a bit more curve goes up there as well. Okay, so maybe I'm still oversimplifying it. Maybe actually what I need is a ninth order function. So I'm going to add another component to my curve and see what happens as I trace the rotation in the x against the y value as the height. And that has got even closer, dare I say, oh, just missed it at the end there. That is very, very, very nearly the unit circle, apart from that tiny bit that's missing at the end. Well, I said at the start that I was only going to focus between 0 and pi. Beyond that, clearly my approximation starts to get worse and worse and worse. And if you zoom out, you can see that it is, in fact, still quite a bad approximation. But every time I add another order to my approximation, I get closer to my result, especially just in this region 0 to pi. And to make that clear, I can draw on the sine function as well. And you can see that in the region from 0 to almost pi, my approximation is the sine curve. And what does it do? It traces out the unit circle everywhere except where we get further and further away from 0, and then it starts to go a bit wrong. There you go. I hope you enjoyed my relationship between the unit circle and the height of the sine curve without using sine.